This is a recording of a study group hosted by El Marquez and Kenneth Armstrong. It's the Linux Operating System's Fundamentals. This study group will give you a high-level overview of the history of Linux, the open source movement, and how this powerful software is used today. Coming up soon, on March 19th, we'll host the Kubernetes Fundamentals study group, and that'll be at meetup.com/Jupiter Broadcasting for the details. We stream all of that live over at jblive.tv. And if you want to take Kenneth's entire course on Linux Operating System Fundamentals, the entire course is free for the month of March for Linux Academy community users. Just go to linuxacademy.com/join for that. You'll find a free community account in there, and you get access to the entire course. But without further ado, let's go learn.
I was just going to say that it looks like you're already kicking us off, and one of the things that I wanted to go over was the fact that Kenny's course is very much oriented to individuals who are just starting out in Linux. So if you're joining us and you're not a Linux pro, don't worry about it, because this is definitely the right study group to be a part of. Kenny, would you mind telling us a little bit about what this course is that we all keep talking about?
Yeah, so I was given the mandate to do an introductory course to Linux without actually showing Linux or even opening up a terminal, which is pretty much heresy within a Linux world. So with that, that's all I was given to begin with. And so I started doing something like, okay, let's just talk a little bit about Linux. But I'm a history major, and I thought, well, let's discuss where this thing actually came from. Let's put this thing into context as to why it's basically a big deal and how it plays in with the rest of the operating system world and with the IT world in general that we have at large. Upon myself to make a bit of a do some technical topics without actually getting too deep into them, just to kind of give people a broader perspective of what Linux is, what some of the differences are between the distributions, and to help kind of guide them towards trying it out for themselves if they wanted to.
Now, one of the things that Chris and I have been talking a lot about is the differences between, let's say, server-side Linux and desktop Linux. What would you say that this course kind of covers the basics for both, with somebody trying to get the history of it, or do you think you kind of slant more one way than the other?
I wouldn't say I would slant any particular way, to be honest with you, because when you get to the core components within Linux, it doesn't matter what you're running it on. If you're running on a server, a desktop, even like an embedded device where you're using it just as a home theater PC system, the core components of Linux are essentially always going to be the same. The ideas behind it, the tooling behind it, the makeup of it, the construction of it is essentially identical between the different types of platforms that you could deploy it to. That's one of the beauties of Linux. Once you have a good, firm understanding of what Linux is, how to use it, then you're pretty much good to go on just about any platform that you come into contact with it.
Over the last couple of study groups, I keep mentioning the Choose Linux kind of distribution challenge that I've been going through and learning to use Linux on the desktop. Now, earlier I mentioned that I am getting to use Fedora and learn it. I have to ask, what is someone with kind of your background and your knowledge? What are you running on your computer?
I have predominantly been a Fedora user for a very, very long time, all the way back to Fedora Core 1, and I switched over to... Yeah, I kick it old school. I switched over to that after Red Hat stopped selling the desktop edition of Red Hat Linux, and they decided to split things up. They decided to focus on enterprise Linux, and a community got together and decided, hey, we still want this to be a regular desktop for people. So they went off with that, and they started the Fedora project, and I've been with it ever since as a user. But I have DistroHop before. I've tried OpenSUSE, I've tried Gentoo, I've tried Arch Linux, Ubuntu, straight regular Debian, Sidux when it was a thing. I've tried a lot of them out, and I would say that I always come back to Fedora because it's just what I feel the most comfortable with.
Yay.
I think we're getting some Fedora love in the Mumble Room there. If you're watching us on the live stream, don't forget to join us in the Mumble Room. You can find instructions on how to do so through the Jupiter Broadcasting meetup page, meetup.com/Jupiter Broadcasting. I'm not as good as Chris at giving that promo, but hopefully it works. So before we get started with actually jumping into a little bit of the history you're going to cover with us, if folks who are listening in want to get started and follow along, what would be the next step beyond taking the course? If they wanted to jump in and actually start using Linux, what would you recommend for them?
Well, after this intro course that I put together, which is like we've already said, it's basically the history of it. And if you actually want to get into the technical meat of the actual topic, then I would suggest, and I'm not trying to do like a shameless plug, but even if it wasn't me doing the course, I would recommend that people go for the LPI Linux Essentials, either the certificate itself, or just take a general course on it. At Linux Academy, we offer a course on Linux Essentials, which is done by me. Again, not trying to do a shameless plug here, but the content that is within Linux Essentials, which it's been put out by the Linux Professional Institute as to what they expect people to understand at that level, covers the basics of some history of the open source movement, different types of distributions, what differentiates between each particular one. You actually have to do some command line work, which is good. So you learn some basic scripting, how to get around on the command line, how to make directories, create tar files, look at log files, do some basic troubleshooting. Just the basic bottom level stuff that you need to know to be a regular Linux user / entry level Linux system administrator.
Oh, that sounds great. All right. Hopefully everyone has had enough time to join us on IRC and in the Mumble Room. So Kenny, if you're ready, you can go ahead and kick it off.
Sure. Wes, do you see my screen at all?
We sure do. I'm seeing both of yours right now. I've got that cropped, so it's just the right half. So if you can change it on your side, it'll be slightly better quality, but otherwise we're good to go.
Okay. I think I've got just like one X server running them all together here, but I'll just run with this if that's okay.
Works. Yeah.
So the topic of this is Linux is obsolete, and that may sound anathema to the listeners out there, but there's a reason why this is titled that. If you've already taken the course, I go into the beginnings of Linux and how Linus Torvalds created Linux kernel on his own accord just because he wanted something to play with. So rather than rehash something that I'd already discussed within the course, which again is free currently right now on the community page for Linux Academy, I decided I would take a component of where Linux began and just kind of expand on that just a wee bit, if you guys don't mind. So the title of this is Linux is Obsolete, a historical look at the argument for the Linux kernel. So we're going to get slightly technical with some theory, but we're not going to get crazy here. So to start things off here, the players of this story, we start with Andrew S. Tannenbaum, who is he's a professor at of computer science at the University of Amsterdam. And he is well known for a book that he co-authored called Operating Systems, Design and Implementation. Now, what this book does is it describes the basics of a computer operating system, the components that goes into an operating system, along with some actual design fundamentals for what you could try to do to code different layers of the operating system. One thing he's really well known for is he is the creator of the Minix operating system, which is a Unix-like clone that was designed for his students, for his courses that he taught, so that people could take apart the code, look at it, try to better understand how a kernel is put together and how it relates to applications that are being run on that kernel. Now, a follower of Andrew Tannenbaum is a guy by the name of Linus Torvalds. And he is a former student of the University of Helsinki in Finland, where he studied computer science. And while he was a student at that school, he developed the Linux kernel, which, again, was something that he wanted to try out for himself, just to try to understand the operating system core components after he read Operating Systems Design Implementation. He wanted to try something on his own. So he created a Unix-like clone that he aptly named after himself, just because that's, when it comes to anything Unix-based, you have to get some kind of nix or nux or some type of sound like that within the title. It seems to be like written in stone somewhere. And he's also well known for writing very entertaining emails on the Linux kernel mailing list. And if you follow Linus's career at all, you know that he's quite vocal when it comes to any type of topic that he feels passionate about. So the concept behind the argument behind Tannenbaum and Torvalds was the design of a kernel for an operating system. Now, I'm not going to get too crazy deep with this because I don't want to bore people to death here with operating system theory. But on the left is a monolithic kernel, which is the core component of an operating system. It's the item that speaks with hardware. It's what handles device drivers, which is the pieces of software that talks to like your network card, your display adapter, your even your keyboard. It also handles how to work with a file system, which is where and how to store files on a computer hard disk, how to read those files, how to organize those files. And it also handles working with your computer's memory, such as your RAM. It needs to be able to map different types of calls. When an application asks for a little bit of RAM, the kernel will handle that for the application by setting aside a location within RAM that the application can speak with. So on a monolithic kernel, all of that functionality is built in with the kernel itself, where you can dynamically load and unload some of this functionality depending on your computer setup. If you have a 3-COM Ethernet card as opposed to an Intel Ethernet card, well, you can load up the Intel driver if you wanted to, and if you had the 3-COM one loaded, then you can unload that one. It all depends on what your hardware is. It's just meant to make the computer operating system run smoother without having to reboot the computer to change pieces of hardware out. Now, this is the design idea that Linux has gone with. On the right-hand side, we have what's called the microkernel, which basically is a lot slimmer. It's easier, in theory, it's easier to maintain because, as you can tell by the size of the stacks, there's going to be a lot less computer code involved with that particular type of software. So the microkernel does basically the same functions as a full monolithic kernel, but in a much more stripped down structure. It's going to do some procedure calls between applications. It's still going to handle access to RAM for different types of applications. It's going to schedule those tasks when, say, an application needs a little bit of processor time to draw a picture on your screen. The microkernel is going to schedule processing time on the CPU to allow that application access to the CPU to do the drawing. Now, instead of having all the drivers and everything like that built into the kernel, like you would have with the monolithic kernel, the microkernel hands all that functionality off to individual applications that will handle that stuff for it. So your ability to communicate with a file system where it dictates how you write your files to a hard disk is going to be handled by a completely separate component rather than the kernel itself. Now, the good thing about that is that with you offloading that functionality to somebody else, you don't have to maintain that code. So that's the sole responsibility of somebody else. Now, Minix uses this particular type of kernel architecture. And Tannenbaum, the guy who came up with Minix, is a hardcore adherent to this design. His belief is that the less code that you have in the kernel, the more secure the kernel can be. So with Tannenbaum being a designer of operating systems and teaching courses in operating systems, he feels or has felt throughout time that this is the absolute way to go. Whereas Linus decided to go with the monolithic design where everything's put into one big single package. So here's the argument from the two sides. And if you look at the actual URL that I put on here, if you go to look it up on the Google mailing list, sorry, my dog's in the background there. The conversation got a little heated between the two of them. So Tannenbaum comes first and says that the reason why the Linux kernel is going to fail and that it is obsolete. And this was written back in 1992. Linus had just announced Linux kernel back in 1991. So within a year's span of time, Tannenbaum comes out and says this Linux kernel idea is terrible. It's not going to work. We're using an older design that was done back in the early 80s and 70s. We're not moving ahead like we should be doing with operating systems. And he decided, or he had the proposal that microkernels, such as what he had used within his Minix operating system and the MS-DOS operating system, which was extremely popular at the time, and GNU Hurd, which didn't quite exist yet, was the format for a modern operating system. And that was the way of the future. New computer software platforms were going to be based on microkernels. And he also argued that the Linux kernel was way too tightly coupled to the 8086 what we now know as the x86 architecture of Intel devices. His complaint was that when you write code for a particular individual processor, such as an Intel 8086, you're going to have an extremely hard time taking that same piece of software and making it run on a completely different processor, such as a Spark processor or a Motorola processor. And again, I'm talking about processors that were very popular back in the early 1990s, just to kind of put this whole conversation in context. And so he felt that his design and his idea for the microkernels was the way to go. Linux was wrong. It's going to fail. It's not going to work. It's not going to work on anything else. It's just basically an exercise of futility. So Linus has seen the mailing list, and he decides, I can't let this go. I've got to respond to this. Now, Tannenbaum is a professor at a well-known university in Europe, and Linus was just a 20-something-year-old upstart who put together his own kernel just for the fun of it. He had no intention of doing anything major with it, but he decides, you know what, I'm going to respond to this anyway. So Linus comes back and says that, okay, all right, Andrew, I'll give you this. Microkernels are actually cleaner in architecture. They're smaller code bases. There's less to maintain. You don't have to worry about trying to get everything packed into one individual package. But there is a speed difference between the two of them. With a microkernel having to hand everything off to other applications, there's that overhead where you have a little bit of a delay. It's a very small delay, but a very little small amount of delay where you have to wait for that communication to come back, whereas the kernel would already have direct access to that information. He also pointed that Minix at the time, nowadays this is different, was not freely available, that you could only get Minix if you were a student of Tannenbaum in one of his courses. And he thought that, well, it's great that you created this operating system for other people to use, but unless you're paying a licensing fee or unless you're actually taking his course, you don't have access to it. You can't look at it and see what you can do to improve on it. And the other problem was that the GNU Herd kernel, which Tannenbaum was touting as the way of the future, it didn't really exist in any usable form at this point. It was more or less just vaporware. It was just this idea that we can have a free Unix kernel that would work in tandem with the existing GNU applications that we already know and love within a Linux operating system. But we didn't have the core component, which is the kernel. We didn't have the thing that actually allowed those applications to talk to the hardware. So that's part of the reason why Linus came up with the Linux kernel, not only to experiment with his own design, but to actually get these awesome tools that were available for free on the internet to actually work on a home computer, which was anathema because most people were just using Unix commands on big hardware, big iron as they used to be called. And another thing about what Linus's argument was that Linux was already available. Granted, it was only a year old at this point. It was just within the early stages of its inception, but it was already available. It was free. You can download the source code and do something else with it if you wanted to. And it was actually working. You can take a Linux kernel and put it on a personal computer, which basically at that point in time, they were still expensive, but at least a college student had a better chance of getting their hands on an Intel 8086 or 386 processor and trying this thing out on their own. It was already there. You could do something with it. And that Linus also pointed out the idea that Linux is portable. You could take the Linux source code and you could try to put it on another piece of hardware if you wanted to. And the reason why that was possible is because he tried his best to conform to what were known as POSIX standards. And we still use these to this day, which means that POSIX is looking for a particular set of instructions that are set up as an industry-wide standard to allow a computer piece of software to be able to communicate with the kernel using particular types of system calls. Now, I know that kind of gets out there in the weeds a little bit, and you can look this stuff up on your own. But basically, POSIX is this defined standard of how a computer operating system should work. So Linus had already worked on that to begin with at the outset to try to be as compatible as possible. He also admitted to sticking with the 8086 because that's all he could afford. That's all he had. I mean, the guy was still a college student, and he only had one machine at that point in time. It was the best that he could use. So he wrote for that. But with the code freely available, since it was open source, people could download it from the internet. then anybody else could grab that same source code and try to work on it on their own to make it work with other types of platforms, to make it work on that Motorola 6800 processor or that big Spark processor or something else that was available at the time. So the outcome of all this, so we had the argument between these two guys. Tannenbaum saying that, look, Linux is going to fail. It's not going to go anywhere. Linus saying, look, I'm just trying. I'm just seeing what I can do with this. I only got this one piece of hardware, but other people could do something else with it. Nowadays, we have Linux everywhere. People have heard about Linux. Not as many people have heard about Minix, but people do know about Linux. The kernel developers were able to port the software to other hardware platforms, which helped to expand its growth. So if you could take the same kernel and put on a different type of computer and still use the GNU tools on top of it, well, that gives you the ability to expand the software base so people can work on their own version of a Linux operating system, write software for it that's portable, and other people on different types of computer platforms could use the same applications. It basically broadened the horizons of the Linux operating system because it was freely available for people to work with. And nowadays we have the Linux operating system that runs on various types of computers, from from the EPC devices that used to be popular to regular laptops and desktops, to server systems that are still running the internet in the background. We have Linux on smartphones. If you have an Android device, the core components of it still has Linux source code within it. Granted, a lot of the libraries around it are all developed by Google, but the basis of it came from Linux itself. The cloud itself, the vast majority of the cloud is running on Linux. You have companies such as Rackspace, the huge one out there, the elephant in the room, AWS. When you go to an AWS management console, the majority of the operating systems that you have to choose from to launch an instance, to get a server running within just a couple of minutes, is mostly Linux. I mean, they do have Windows offerings, but even the platform of Amazon Web Services itself is actually using Linux underneath everything. Embedded systems, like I talked before about home theater PC systems. We also have GPS devices that were using Linux embedded within them. Linux has made it into space on various types of space platforms, such as companies such as SpaceX. They've used modified versions of Linux as well. The US military has used Linux in a multitude of capacities. So Linux did essentially win out against the Minix idea, but there is some caveat to that. Also, I just want to point this out, though. Even though there was the argument between Tannenbaum and Torvalds, they have no ill feelings towards one another. They're actually on good, friendly terms with each other. And Tannenbaum wanted to point out that you can have a disagreement over ideas, but that does not mean you're going to actually hate the person. And he really wanted to make that point apparent, because people were trying to take sides with, oh, well, Minix is better, well, Linux is better. But the two of them were like, look, we disagreed on one architectural thing. When a user sits down at a computer, do they really care what's underneath the hood? No, they're there to try to get their work done. They're there just to try to get their word processor up and going. They're trying to get their server going. It's just an architectural idea in the background. So why does this even matter? I mean, why do I even bring this up? Well, I just wanted to point out that the point of history itself is to learn from it. And there is one particular takeaway that I think about when I consider the topic of the argument between Tannenbaum and Torvalds, is that Linus had something usable first, before GNU Hurd even had anything available. And the reason why I'm focusing on GNU Hurd is because the GNU project had all of the replacement Unix applications already available for people to use. People who wanted to get away from the very expensive, high-priced licensing environment of the Unix operating system were able to use replacement components from the GNU project. So when they had certain types of applications such as LSCP, the tar commands, things like that, they could use components from the GNU project for free without having to pay any extra licensing problems. The only thing that they had an issue with was that GNU didn't really have a kernel at the core of it to create their own full-fledged operating system. They had the design and the idea for Hurd, but the kernel didn't exist. Linus solved that problem on his own his own volition by coming up with the kernel that would work with the GNU project. So he came out with something before Herd even came into full-fledged being. And that also brings up another concept, is that there's an old book that's been around since the 1400s by a guy named Hans Talhofer, and it's a medieval manuscript on sword fighting. This guy traveled from city to city teaching rich barons how to do two-handed sword fighting. And the number one rule that he told everybody was that you need to be there first. If you're going to attack, even if you're going to defend, sorry, my dog is still in the background there. You need to be there first with whatever action you're going to take. Linus was there first. Linus beat Herd to the punch with a full-fledged kernel that was able to work as a free alternative to the high-cost, super expensive Unix projects. So that kind of goes back to the idea of the old software design adage, where you need to release early and you need to release often. And what that means is that you need to keep the feedback loop of users and software creators moving to help improve the software. So by getting your software out there first, getting it out there quickly, people can try it. People can use it. They can help you find those bugs. They can help provide ideas, and they can help improve on it by providing the recommendations or even fixes themselves back to the original creators, who can then improve on it themselves and keep that loop going. Keep the loop going, so this way the software itself is constantly improving rather than waiting on some big batch feature upgrade where we're going to wait 6 months while we develop this one thing and we're going to test it like crazy, make sure it passed all of our internal tests before we release the new version. Whereas with this concept and what Linus was doing with Linux was put the code out there, constantly improve on it, listen to the feedback coming from people, and try to take their input into consideration to see what it can do to help improve the core software. And that's one of the strengths about Linux and the open source movement, is that with everybody having access to it, everybody has a voice, everybody can provide their input, then it just continuously gets better. And it's just a nice, to me, it's a bit of a superior model over the closed source idea where depending on how many support tickets come in for a particular problem, then that's the feature we're going to work on next. And a lot of the times those support cases will get ignored unless it's coming from a really high paid customer. Whereas the open source movement, everybody's got a voice. So and just for some further reading, in case you're curious, there's a nice article about IBM making an attempt to work on a microkernel themselves, and it failed miserably after they spent billions of dollars on a project. And they even bring up the Linux kernel as to how a monolithic kernel worked better than the microkernel idea. So if you're curious, you can take a look at that article. There's also there's the email thread itself between Tannenbaum and Linus Torvalds himself is listed on the second link there. So if you want to read the thing in full, Linus does get a little heated. I just want to point that out there. So it's interesting reading his work, because he kind of gets when it came to Linux, and it's still when it comes to Linux, he takes it to heart, because that's basically his baby. And if you want to read a little bit more about the different types of architectures between kernels, I've included the Wikipedia articles here for microkernel, the monolithic kernel, and a hybrid kernel, which if you are a user of the Windows operating system or the Macintosh operating systems, that's where your kernel comes into play. So that's essentially it. I just kind of wanted to point out a single argument at the very beginning of Linux's history between a well-known author and creator of a clone Unix operating system and a guy that was just starting out on his own with the hobby project, and how just one design argument between the two of them kind of helped to blossom into what we now have today with the Linux environment altogether. And to point out that if you're there first with a good idea, that doesn't mean you're going to be successful, but you have a very good shot. And Linus is good proof of that, of being somebody that was there first with an idea and was successful with it. And that's what I got.
Wow, that was great. For those of you who have not had the privilege of learning from Kenny before, I think you will probably join me in telling him that that has to be one of the smoothest presentations I've ever been in. I really enjoyed it, and I really love the history behind it, because I've been in the Linux community for about 5 years, and a lot of it becomes kind of folklore, and you don't really know what to believe. So I really love the links that you shared, so we can go back and read up on it. I was going to ask you, how did you get started? How did you get started in the Linux community?
I started kind of like in a sideways manner, basically. Of course, like many people back in the 90s when we first started on computers, as a general user, we started out on Windows, and that was pretty much all we knew. When you work on a computer, that was it. We had some friends that were using like old Macintosh System 7, System 8 boxes, and we loved those because they looked prettier and they had really cool multimedia. But for the most part, when you got your first computer, it was a Windows box. And then I got into the Army, and that's when I got introduced to Unix in general. I was a missile systems technician, and we used a system that was using a very stripped down copy of Solaris Unix. And I was like, whoa, this is different. And I actually got introduced to the command line and how to navigate things. And I was like, man, this is pretty solid. And when I got in the military, I went to go work for an ISP. And this is when I learned about Linux, that there was this variant of Unix that you could actually use at home. And back during this time frame, you were able to actually go to a big box store. In my case, I was in Podunk, South Carolina, basically at a Walmart. I look on the shelf, and there's 3 different distributions of Linux, one from Red Hat, one from Mandriva, and one from SUSE, that you could actually buy, that came with all the software and probably about maybe 9,000 pages in documentation and actual paper that you could take home and install on a personal computer. I had built my first computer at this point and couldn't afford Windows because it was just ridiculously expensive. But I could drop down a $20 bill and buy a full-fledged box copy of Windows. And I started out with Red Hat back when they were selling in stores, and it had all the software that I needed with it. And I started off with that, and I haven't looked back. So.
Oh man, that's a great origin story. And it really makes me think about how much Linux has changed and how easy it is compared to what you had to go through to get started now with the use of like live CDs and live USB keys. I'm going to introduce one other person who a lot of the Jupiter Broadcasting community probably already knows really well. But if you're new to Linux or you're just starting out and that's why you joined us today, I'd like to introduce you to my friend Joe, who has a great podcast who might help you along the way called Choose Linux. Joe, would you mind telling us a little bit about the podcast and kind of why y'all got started?
Yeah, okay. It's Choose Linux, the show that aims to capture the excitement of discovering Linux. And so I started the show with Jason Evangelo, who writes for Forbes, about his journey. He's recently got into Linux. He did, about 10 years ago, get into a bit of Red Hat and stuff, but he kind of thought that was a bit too difficult and, too stressful. So he was using Windows for a long time and Mac OS, and he was doing reviews of graphics cards and gaming stuff. And eventually he just got so fed up with Windows and all the problems there that he decided to give Linux another go. And he started writing about Linux, and suddenly he just managed to grow this community just almost instantly, because it was something that you wouldn't expect to see from Forbes, because they'd never published any Linux content before. And all of us were just kind of so we were reminded of what it was like when we first got into Linux and the excitement and that Jason was showing us, and I just thought I have to do a show with him. So I got in contact with him, and we've been doing it for a few episodes now, where we just talk about all the stuff that he's been discovering. And I'm kind of a little bit, I've been using desktop Linux for about over 10 years now, so I'm a little bit jaded and cynical, whereas he's this kind of fresh-faced enthusiast. And so I thought it might work quite well, and it seems to be going quite well so far.
Oh, that sounds great. I enjoyed the first episodes, and I really like I don't want to say the banter between you two, but it's very much done in a conversational tone as opposed to a preachy tone, which I get from some people when they're fairly starting out on their journey. So thanks for adding that to the community. For those of you who might be around at Scale, make sure to join up with us at our Scale dinner, and you'll have an opportunity to talk with Chris and Wes and myself. And if you're going to be going to Linux Fest Northwest, I know, Joe, you're going to be there, right?
Yes, I will be there, yeah.
So you'll get an opportunity. And Kenny, I think you'll be there as well.
Yeah, I'll be there doing an exam cram for the Linux Professional Institute. So if you're looking to study for the LPIC 1, I'll be there conducting some sessions for them.
And also, if you have an opportunity and you follow me on Twitter, today is the last day to vote on what you're going to want to be seeing with these study groups. We're going to turn focus and do more of a kind of full-oriented study group where we talk about just AWS or we talk about just security. Those are the two front runners for the next quarter. So definitely get your vote in. But for now, the next study group is going to be run by my great friend Chad, and we're going to be covering Kubernetes. So make sure to check the Jupyter Broadcasting meetup for that. If you have any questions that we didn't get to, make sure to check the community GitHub that we have set up for our notes. You can add information there and reach out to us with any questions that you'd like to see there. Kenny was kind enough to help me put together 2 exercises that if you're new to Linux, you can give a try and see if you can get yourself oriented around the command line. So I'd love to see what y'all are experiencing there. Chris, you want to have any parting words for us?
No, I just wanted to say thank you very much, Kenny. It was a very, very great course. Took the whole one myself, but I also really appreciated your summary today. And I guess my only last question is, Kenny, what kind of dog do you have?
She's a blue beagle, and she's loud.
Well, I'm glad she could join us.
Yeah.
Thank you, Kenny, so much. Thank you we really do appreciate it.
Thank you.
All right, guys. Well, join us next time. Until then, have a great evening.